So, hopefully you've had a chance to work through the first two parts. I apologize if this video seems kind of disjointed with the first three. The original video I made, it was pointed out that I made a mistake in my calculation, so I'm re-recording the final part of this. So, hopefully you've gone through and you have, for question number 4, you've created the FBD, and we have also, you've calculated the forces, the up force and the right force. Okay, so if we start by looking at these three charges, okay, I've labeled them Q1, Q2, and Q3 in order just to make them a little bit easier to identify. We care about the forces acting on Q2. All right, so we drew the FBD because this is negative and this is positive. They are attracting each other, so this negative charge is going to pull it up. The same thing is true for this one on the right as well. It's negative, the other one is positive, so the negative charge Q3 is going to pull Q2 to the right. Now, once we do that, to actually calculate the forces, we are going to use Coulomb's law because these are electric forces. All right, that's going on here. So for F12, we go in here, we calculate the electric force. I do want to point out that this is something that was kind of brought up to me earlier. What's the point of all these things that go in front of the C? It's just to add a little prefix, all right? So there's the idea that basically, just like with meters, you can talk about kilometers, which means it's just a prefix. This is the same idea. So this little n represents nanocoulomb, which means it's 10 to the negative 9th, all right? Which is why these are 10 to the negative 9th. The ones in the previous problem that were 10 to the negative 6, all right, that would be the first question. Those were microcoulombs, just to kind of clarify why I'm picking what I'm picking, all right? So going back to the question, I know the charges, I know how far away they are, the distance between them. If you watch the original video, this is where I accidentally made a mistake. I forgot to divide by the distance. All right. So if you go through and do the proper calculations, you should get that the up force, the force between charge 1 and charge 2, is 5.75 times 10 to the negative 7 newtons. And it's pulling it. And of course, once again, I've already messed up. F12 should be pulling it up, so I apologize. I don't know why on earth I drew those two arrows. So it's pulling it up. F23 in charge 2 and charge 3, same deal. Calculate it out. It's 8.63 times 10 to the negative 7th newtons. This should be going to the right. So again, I have butchered this. So you can basically ignore that. Ignore that. This is going right. This is going up. Okay? Now, once you have those forces, the last piece of this, to actually find the true net force. Remember, at this point, we're just going back to stuff we know about forces in general. So we're not really worried about electric forces anymore. So to figure out the true net force, we have to make a triangle. All right? In this case, all we have is the components acting on this charge. So to find the true net force, we take those two components, as you can see right here, and we make them into a triangle. So right, up. The net force is going to be whatever the hypotenuse of this triangle is. All right? And then same thing, to find the angle, that's the last piece of this, you need to look at that triangle. This is going to be the angle. Use SOHCAHTOA. All right? As you can clearly see from my notes, I'm using tangent, but honestly, if you calculate the hypotenuse, you can use any of the three. It's up to you. So I want you to take as much time as you need to. I want you to work through this question and try to calculate what the net force should be and what the angle should be. So just pause the video here, take as much time as you need, and when you're ready, unpause it and see if you agree. All right, so hopefully you have a chance to work through these two sections. So just to talk about real quick what it is, if you use the net force just like we discussed, I want to turn this off. If you go for the net force and you use Pythagorean theorem, you should get, working through all that, you should get that the net force is going to be 1.04 times 10 to the negative 6 newtons. And remember, all we're doing is making our little vector triangle. The net force is going to be the hypotenuse. So that's net force. And then if we go through and look on the right side, if we're using SOHCAHTOA, all right, so I pick tan of theta. Opposite side that's the side opposite theta, which I have as F12. Adjacent is just F23. I get theta by itself, work through it, and I get that theta, the angle it makes, is 33.67 degrees. All right, so the full answer, when all said and done, is the net force acting on the 8 nanocoulomb charge is 1.04 times 10 to the negative 6 newtons, and it is acting at a 33.67 degree angle. Okay, so hopefully this has kind of been a good practice, not only using Coulomb's law, but also reminding ourselves of the rules of forces that we have known pretty much from the time we started talking about forces that still apply here. Okay, so once again, if you have questions, please come either send me an email, find me during office hours. Otherwise, the WebAssign is similar to this. Use this as a guide, work through it. You get plenty of chances to kind of make mistakes. If you have questions, just contact me. All right, otherwise, have a great rest of the day.